Okay, so Dr. Arpan, good evening, and thanks a lot. You gave me your time for the interaction today.
Yeah, good evening, Dr. Vijayendra. Thank you for inviting me here.
Okay, so Dr. Arpan, you are presently serving in IIT Mandi, and some of your research areas in which you are working are acoustics, vibrations, e-vehicles, and metamaterials. And I'll be discussing with you related to these areas. And also, you are doing very good work in the field of NVH. So we'll be knowing more about this particular thing from you. What are the various domains in which you are working? So I have collected some of the interaction points. So if you permit me, I will start one by one.
Sure.
Okay.
Please go ahead.
Yeah. So Dr. Arpan, my first question normally is related to the personality whom I invite. And I was going through your profile. You have done your graduation BTech from IIT Delhi in mechanical engineering. And then you went to National University Singapore, NUS, prestigious university. And you did your PhD from there. And as per my knowledge, you have not done your master's. So now this is normally called direct PhD, and this lot of students are actually having some kind of dissonance whether they should go for masters or they should directly go for PhD. Why you should go for directly into PhD without doing masters? So what is your take on that?
Okay, so there are some advantages and disadvantages of both. Direct PhD, yes, it's a program that is being offered at many places, many universities, and even in many, even our IITs and various places this program is offered. Now, the advantage, so the question comes, who should go for a direct PhD? I think one who is really good in academics and one who is really motivated for research. He or she should go for a direct PhD program. Because when you are going for a PhD program, it's a big bet that you are making, right? So PhD is not a easy thing. There are frustrations associated with PhD. There is a lot of, it has its own challenges. So, directly going for a PhD, I think there should be a very strong inner call, an inner conviction and inner determination that that you want to do research. You should be interested in research and knowledge, learning about nature, learning about science, how things work, learning about the engineering systems. So if that is the that is the inner call, and as I said, you should simultaneously, one should be good in academics. So that is, and particularly being good in academics means having a good BTech degree with good academic, records. That will help in, having a good PhD. See what I say, see that BTech is like ABC. See, when a person graduates after 12th and then you get into a BTech program, it's not that immediately you learn everything about engineering. You have just started to learn about engineering. So BTech, I would say, is just an introduction, but then there are lots and lot of things to be learned as we go along. And I would say even now I am also learning, right? So learning never stops. And if we are committed to that kind of learning, then I think PhD is a suitable program. So that's about direct program. Coming to your second point, that there are some advantages of doing a master's program. See, one thing is that see, everybody may not have got a very good BTech degree from a very good IIT or very strong foundation. So you need to have a strong foundation. So doing an MTech from a good place gives you that strong foundation. Plus, it also helps you to broaden your outlook. See, PhD means you are going deep into a small hole, right? So your supervisor or you get a PhD problem, which is a very small, narrow problem on a very small topic. And then you just keep on going deep into that problem. And that's what I would see most of the PhD cases, right? So we just focused on a narrow thing, but then we try to go in depth as much as possible. As a result, we lose that overall breadth in engineering. So I think doing a master's program, which essentially has got various, multiple courses. So that gives you a different perspective of various concepts, which are, I think, very helpful. So, so that is very important in, and it also helps you to evaluate whether you are suitable for a PhD or not. Right. So whether you are able to take that rigorous analytical things or computational things, doing experiments, all these things are parts of a PhD thing. So I think that is, so it has its own advantage, having a master's and then evaluating whether you want to go for a PhD or not. Now, regarding if you ask about, personally for myself, when I was a BTech student, I was fortunate and to do master's level courses in my BTech.
Okay.
So in your question, you said that, well, I did not do a master's program. So yeah, I may not have a master's degree, but I have done, so I did my BTech from IIT Delhi, and I did master's level courses and PhD level courses at IIT Delhi. So I think that flexibility is there in most of the IITs, we offer here as well. So we have a common courses, and in third year and fourth year, students can take elective courses, which can have components from, PhD or MTech level courses. So, so yeah, I was, as I said, I was lucky to have good teachers to teach me some of these very wonderful courses. And I did all of my electives in the area of mechanical design, in the area of vibrations and acoustics and these types of topics. And that kind of ignited my inner self that, okay, I should really pursue a PhD in this area. So that led me to this going for a direct PhD. And of course, there was one more reason is, I don't want to burden my family. So I'm from a medium family. And so I had opportunities in other places, but then there was some, so I was able to get scholarship as well. So that was another reason for me to get.
Yeah, because in PhD, you get more scholarship, obviously, compared to masters. And sometimes
it depends, actually. It all depends upon your performance, upon your background. Yes. And even admission in direct PhD, it also depends on. So fortunately, I had a good academic record, and also had done some research work in my BTech level. So that thing really helped me to get a good,
Dr. Arpan, we know there are two reputed universities in Singapore. One is National University Singapore, another is Nanyang Technical University, NTU. Right. So I get this opportunity to interact with you. So I want to ask you about these universities also. So normally students know that these are the two universities in Singapore, but they don't know the difference, if at all there is some difference between these two universities, like what kind of university these are. All we know, they are very good universities, and maybe first choice for people in Asia, at least because of the proximity. So please tell us something about these universities also.
Yeah, both of these universities are world-renowned universities. Yes. And out of them, I don't know about the recent ranking, but in general, I think NUS was among, one of the top in Asia, and even in the world, it is in maybe top 20 or something like that. So, but yeah, both are good universities, and in going for a PhD program, as I said, so if there also we have to have clear the exams and have evaluations. Now, in case if you don't perform well, they may even downgrade you. Okay. So it is not that just getting an admission is sufficient, but they have to perform throughout the course, and otherwise they may downgrade to a master's degree, or sometimes they may, so those things are also there.
Okay, Dr. Arpan, many students, even if they are naturally inclined for academics and research, and they want to go for PhD courses, one thing which they have in their mind, which may stop them from pursuing forward, is the duration of the PhD. There are different kind of thinkings among students that duration may be very long, and what if we don't do it? So it's a course which requires a long commitment. I want to ask you, like, what is the duration of PhD, or for that matter, direct PhD, and is it going to be very arduous?
Typically, it is around 4 to 5 years. That's a typical number. Now, some places can be less, some places can be more. It also depends upon supervisor, and it also depends upon the candidate. So there are there are exceptional candidates, and I'm sure you might have interviewed some professors who might have finished their PhD maybe in 2 years, or you know, and sometimes PhD need not be completed, right? So those cases are those kind of cases are also there, where after going through 4 or 5 years, if even at NUS, you know, if we find that, you know, the person is not doing appropriate good quality work, they may not even you know, consider that. They may downgrade it. So it depends upon various factors, various parameters. You know, supervisor is a very important.
There's so many parameters.
Yeah. So, supervisor and his guidance is a very important parameter. But yeah, typical number is 4 years. 4 to 5 years. Yeah.
After PhD, I suppose you started working as a scientist at Institute of High Performance Computing, which is A-Star Singapore. We want you to tell us something about A-Star. What is A-Star, this particular company? Tell us about this.
So it is a government organization, to my understanding. So it is basically Agency for Science, Technology and Research. A-Star. So it's a government-funded entity which has got multiple institutes. So it does research, it does cutting-edge research in the area of practically everything, you know, environment, biology, you know, engineering, etc. Right? So it has got various institutes under that thing, and I was working in what is called as Institute of High Performance Computing. So it basically looks more on computing aspect and the engineering aspect of things. So so that is what yeah, was after my PhD I worked there.
Okay, wonderful. Dr. Arpan, the viewers on my channel, they are those engineering graduates who are looking forward to pursue their career in research and academics. So the domain in which you are working, which we acronym NVH, noise, vibration and harshness. I request you to please explain us about this particular acronym, NVH.
Okay, noise, vibration and harshness, NVH acronym, if you are asking. So that is more related to automobile engineering. If you are if you want to go into the automobile sector, then yes, then they have this term called as NVH. So basically, noise is any unwanted sound is noise, vibrations and harshness. So that's NVH. The idea is that we want to reduce unpleasant noise and unpleasant vibrations. So NVH is more prominent, as I said, in automobile, but it is there everywhere, right? So let's say in my office, if I've got a printer, if I've got a laptop or a desktop, so it's the sound that they, you know, so if something produces a lot of unpleasant noise, as a customer or as a consumer, I won't like it. If something makes less noise, or if it gives me a better environment, I'll be more happy with that, right? Same thing is with vibration. So if something is vibrating a lot, and I'm sure modern cars, as you know, we are all experiencing that how the quality of cars has improved over
yes,
so many decades, and so all these scientific and engineering knowledge goes into improving the research of whether it's automobile, and as I said, you know, printers, fans, washing machine,
yes,
you name it, right? So mixer, grinder, any moving part, any machine which has got a moving part, yes, it will produce some vibrations. Vibrations will produce noise. Yes. So the idea is how to reduce the vibrations, how to reduce the noise, and these things not just deteriorate the, excuse me. So these things not just affect the, so there is things related to human psychology, and how it relates to our perception of noise, and these things are also detrimental for the component itself, right? So if a car is having a lot of vibrations, the wear and tear in the car and car components is going to increase. So yeah. So the idea is all about to sometimes reduce it. Nowadays, some research is also going to make pleasant sound, right? To make more sound which is more pleasant, more audible, right? So for example, and some companies, they bank on that sound. For example, these Harley Davidson or those kinds of bikes, they have their particular sound which are
This is their USP actually.
yeah.
So Dr. Arpan, this typical kind of sound which is generated, as you gave example, is that also part of NVH, or NVH is all about vibration or sound isolation only? I mean, creation is also part of that.
See, it all goes as a complete whole part, right? So you cannot just study the sound of a muffler, right? You have to, or sound from an IC engine. You have to. So I would say the whole area is about acoustics. I mean, if you are talking about sound, and it begins with vibrations. So acoustics is even a little bit more advanced level or a little bit more complicated. So the basics are topics are related to vibrations. And then sound is produced by two main mechanisms. One is by vibration, and second is by flow, turbulent flows, or some kind of flows. So that is again that's again a separate domain. But even if you just consider noise produced by vibrations, they are coupled, and it's a very complicated system, and it's a complicated study actually. So so it goes as a total part and parcel, and then there are different ways of controlling noise. So you can control the noise at the source, you can control the noise at the path, and you can control the noise at the receiver. Right. So there are three simple ways of, let's say, if I want to reduce the noise, right? So let's say if there is a fan and it is making a lot of noise. So one way is I can balance the fan. So that's one simple way of reducing the noise at the source, is by balancing machines, or by using machines which don't produce a lot of unbalanced forces, right? So again, these terms are specific to mechanical engineers. So that's one way, to have better machines. The second way is if you have a path, then you can, like mufflers. So mufflers are basically you try to reduce the noise between the path. And if nothing works, then you just have to put an earplugs. And so at the receiver end, you can put some earplugs or ear muffs to muffle the sound. So that's a typical strategy of controlling noise. Yeah.
So we understand, Dr. Arpan, that this vibration control is one of the very, very important domain.
Correct.
And you mentioned many applications, and automobile, even daily metro when we travel, and metro when we travel, we find that the use of vibration they must have done. But there is another point where I want to bring your attention to, and that is course curricular which is there in the colleges, engineering colleges. We see that many of the engineering colleges in mechanical engineering and all, we do not have vibration as a subject in UG level, and certainly noise as a topic in that is not there. So what do you think, how important is, I mean, this kind of topics, when we know that we require a lot of professionals of this particular field, specialization, vibration control, vibration noise, but we don't have that in curricular part of the colleges?
Yeah, definitely, it's a very important topic, but I won't say that we require a lot of professionals. Producing a lot of engineers can again have its own problems. So now this is a very specific area, and see, it all depends upon what interests you and what inspires you, right? So if you ask me, for me, it's a very interesting and very, very fascinating area. So rather than just noise, just the sound and vibrations is a very, something that you can perceive yourself, right? Whether it's a good music, there is so much research in effect of good music on health. Even at IIT Mandi here, we have some programs on Indian health, Indian music and all those things. So there are a lot of things, aspects are there which are explored and unexplored. So coming back to your question, yes, it is important, and definitely I wish those things can be taught. But having said that, engineering curriculum is limited. it is very difficult to pack so many things into engineering curriculum. And nowadays there is a demand for a lot of other things as well, right? So whether it's entrepreneurship or whether it is other disciplines, learning about so a student should be trained in giving a breadth, but that option should be also provided that if somebody wants to go into depth of vibrations, then that option should be there. And for that, we need good faculties to teach that course. This course, these are some of the, I would say, advanced topics. And as I said, I was fortunate to have teachers who taught me so well that sparked that interest. So that thing is required, having good teachers. And when it is there, then definitely students will benefit, and then they can take it forward to higher levels of research.
Dr. Arpan, as I mentioned in the beginning, one of your research areas is metamaterials also. We hear this word as buzzword nowadays, metamaterials. So my next interaction point is related to that only. So what do you understand by sonic crystal and what is metamaterial? So what is the importance of these terms for NVH?
Okay, so coming to this point, I would say this is my main area of research.
Okay.
NVH is, you can say, an application for this thing, but that's my core area of research. Metamaterials and sonic crystal is basically any repetitive structure. It's all about periodicity. So when there is periodicity of certain objects, and when some wave interacts with a periodic structure or a periodic obstacles, then some interesting phenomena happens. And the study of this interesting phenomena is what is the area of metamaterials and sonic crystal. So what is that interesting thing? So let me first of all show you what it looks like, something, just to give you a demonstration. You can see this kind of structure.
Yes.
This is some brass cylinders, a periodic structure of brass cylinders. Okay. This is a small sample of what we use to in our experiments. Okay. And when I impinge sound waves on it, right? So just by some speakers connected with some audio generation devices, we have some sound inciding, exciting this structure, and then we measure it on the other side, right? So then what happens that some frequencies, it's an open structure. You can see here the gaps, right? It's an open structure. So some frequencies can pass through this structure freely, but some frequencies are strongly reflected back. Some frequencies, they just cannot go through this structure and it just obstructs that particular sound. So this kind of structure, which is a metamaterial and which is for acoustics, we call as sonic crystal, this behaves as a frequency filter. In fact, if we were to have a physical interaction, I would have even demonstrated this, interesting thing where you could hear it from your ears, the difference of sound propagating through this structure. So the interesting thing that it does is that for some sound, it is like transparent. It can just allow some sound to go through for some frequencies. And some frequencies which are based on the design of this structure, they will get completely obstructed. So using this, we have some projects. We even had some patents. So we had tried to implement these things for some situations where we have noise of a dominant frequency. So when we know that some sound has got a very dominant frequency, we can design this structure, and then this structure will be an open structure. So we can have even air ventilation we can have, but a sound in that particular frequency will get attenuated. So that is a very interesting thing about this thing. We are also trying to use these things for metamaterials for seismic protection of buildings. So if instead of having acoustic waves, now if I have elastic waves or waves in the in the seismic wave, let's say earthquake waves. So we are also trying to work if we can use these structures to reflect back some sounds, some waves, seismic waves. So that is another very interesting area of research currently we are working upon. And of course, it is challenging, it is difficult, and but yeah, things research is going on. Yeah.
Yeah. Professor, one of the typical example of control of vibration and noise is what we see as silencer in motorcycles, in vehicles, and all. We see that. My next question is related to that only. So, if a vehicle is not having silencer, then obviously there will be unbearable sound which all of us can hear. So, this engine noise, exhaust noise, can be very well controlled by silencer. So what is present inside a typical silencer, because everybody sees it and they are inquisitive, uske andar kya hota hai? What is there inside the silencer which so drastically reduces the noise of the engine exhaust?
Right. So silence is again a wonderful design, wonderful system of acoustics, which and in India we have one of the pioneer in that area, Professor Munjal. So silencer is basically, so let me first of all show you that thing, then I'll talk about it. Okay, so this is a typical silencer that I think an old scooter silencer. We have actually cut it out, and I would like to show you that thing. Again, I use for my teaching demonstrations. So this is a silencer. Now if I open it here, it has got some absorptive lining, right? So this is basically some kind of a glass wool or mineral wool, which is mounted on one side. And now if you see on the inside part, you will have a lot of change in areas, right? So there are a lot of change in cross-section areas. So you can see this is the inlet of the silencer. The exhaust gas comes from here, and then it comes here, and then there is a sudden opening. So when there is a sudden opening, there is what is called as impedance mismatch here. And then now from here, the exhaust gas has to go through these holes. You can see the holes here, right? These holes. So then from here, it will go through these holes here. And then again, there is an impedance mismatch. Then from here, it goes into this hole here. Again, there is an impedance mismatch. Then from this hole, it will again come, and then there is a hole which goes to this exhaust pipe. So there are a lot of change in cross-sectional area. This change in cross-sectional area is basically what is your impedance mismatch. So there are two ways by which sound is reduced or muffled, right? So muffler is basically it's used for muffling the sound or reducing the sound. One way is absorption. So you can see there is an absorptive material here, and here also you can see some white material that is also the same absorptive material here. So that's the absorptive thing to absorb the sound energy, and that dissipates into the heat, right? So that's one way. The second way is a lot of impedance mismatch, changes in cross-sectional area in the path of propagation of the wave. And that you can see a lot of areas here. So that reduces the sound. So these are the two phenomena. These are the two phenomena for reducing the sound.
So, Professor, we have, if we keep on, as you said, difference of the area is one of the criteria. So, do we have different kind of silencers where maybe 2 layers which you have shown, maybe there are 3 layers, 4 layers, or a different kind of style for silencers also?
Yeah, of course there are different designs, and of course I have not cut and open all the various kinds of silencers, but yeah, different designs, and different OEMs will be having different designs, different types of absorption, different layers of absorptions. Here it had a very thin layer of absorption, and yeah, so that internal design is what makes that difference.
So there is another term which is related to this only, and that is acoustic enclosure. So I request you to explain us about that particular term. What is an acoustic enclosure and what it does?
Okay, acoustic enclosure is, I think you might have seen from my website. So we have a small chamber, a room for doing acoustics related experiment that I call as an enclosure. But that is not a very good, not a standard way of doing experiments. So the standard acoustic experiments are performed in what is called as anechoic chamber. Anechoic chamber is a specially designed room to simulate free field condition. Free field condition means if I, just like in this room, if I'm speaking, the sound is getting reflected from all the walls and it's coming back. So if when I do a measurement here, it is not the measurement of what I'm speaking, it is the measurement of what I'm speaking and what the reflections are. So acoustic and this anechoic chamber is a room which has got a lot of absorptive, very heavy absorption all over the place, and very specially designed room, so that any sound goes, it will just get absorbed, it will never come back, or it will come back very minimally. So then whatever measurements we do, they are actual or good acoustics measurements. And ideally that is what is required for doing all acoustics related experiments.
So there is another term also, Professor, which is related to this only, that is acoustic levitation. So, and also you have one patent on acoustic levitation of large spherical objects at low frequency. So can you tell us about that term also?
Okay, so acoustic levitation is using the sound waves to lift objects in a non-contact way. That's what, and one of my students had worked on that idea. The idea actually stems from various maybe let's say ancient temples or various places, whether it's in Egypt or in and abroad, in India as well as in abroad. There are many such structures for which it is not very clear how these structures have been built.
Yes.
At that time, we don't have the present day heavy machinery, heavy equipment. So how these structures have been built, and one of the possible reasons that is proposed is by sound.
Okay. So
sound has got very amazing effect. It has got a lot of power, but it depends whether how much we are able to harness it or not, so on. So this study was actually try to explore that area. Unfortunately, we found that as far as modern science and research is concerned, and even what we were able to do is we are able to levitate only small, tiny thermocol balls, right? So as far as modern science is concerned, that's what even we are able to do. So we are able to, but yeah, then we were able to, so using sound, we were able to create a system to lift objects, and then we were also able to move objects and do some maneuver.
Do we see a lot of scope of these kind of things, Dr. Arpan, in India also?
Yes, so this kind of things can have a lot of scope in the sense that, let's say you want to study the physics of surface tension, you want to study how some particles behave, how in a non-contact way, you don't want to contact them, you want to provide a levitating environment. So that is one area, related to research. We want to do research in that. We want to study the coalescence of bubbles or liquids. You want to see how the things mix when in a non-contact way. Also, if you want to have highly reactive materials or very sophisticated devices, you don't want to touch it, but in a non-contact way, you want to lift it and then move it. So we had developed some kind of these technologies for a small particle, small, as I said, like thermocol balls or even some small lightweight objects. We were able to lift them and we were able to move them over a distance. So that's what we, the work we did in acoustic levitation.
Yeah. Professor, when you work
lastly, you were asking about the patent part. So it has not yet been approved, but yeah, we did an interesting experiment where we were able to levitate a table tennis ball.
Okay.
So that's so that's but that's a work still under progress, not fully completed.
So when you study all these areas, all these subjects which we are talking about, there is a requirement of finite element method. So FEM is very, very important, and you are using FEM in most of your research works. So why often we observe that there's a lot of difference between what results do we get through FEM and what otherwise we get through experimentation?
Difference, it depends upon which area you are using, using FEM for.
Okay.
If you are using FEM for sound and for acoustics, definitely there will be difference in results, because it is very difficult to do good acoustics experiment. That is one. And secondly, on the finite element side, it's very difficult to model the realistic boundary conditions and realistic sources, realistic things in finite elements. So both ways it has its challenge, and that's why I would say acoustics is a difficult area. So so if you want, so finite element has limitations, but it gives a direction. It gives us an area, so let's say finite element predict 70 or 80 decibel of noise reduction. 70, 80 decibel is too much. In experiments, we at our laboratory scale, we may get up to 40 decibels, 50 decibels. We have to be happy with that. And again, the pursuit to improve it is going on, right? So we are trying to continuously improve with our experiments as well as our finite element simulation. So yeah, so there are ways of improving FEM simulations as well, and the work is going on.
Okay. So Professor, now I'll come to again automobile sector, and that my next question is related to the difference which we find between Volvo buses and roadways, typical roadways buses we have. All of us are aware the kind of ride we can have on Volvo buses, thanks to very nicely designed, I think, structure of these buses. So my question to you is vis-a-vis vibration, how typical vibration engineer designs such kind of structure. So what is there in these kind of luxury buses like Volvo buses, which give so much comfort as far as the vibration is concerned for these kind of vehicles?
It basically depends upon the suspension design.
Okay.
And that again goes completely in the area of NVH.
Okay.
So related to your point, it's all about suspension. So if you see old trucks or roadways bus, very simple buses, they'll be using either leaf springs or coil springs. Right. So if you remember, so if you can see these kind of leaves coming at the back of the trucks, those are leaf springs. And then we can have some simple springs and dampers. So those are coil springs. So typically they require less maintenance, and they are economic, very cost less. Maintenance is minimal, and therefore for these applications they are used. But obviously they have their drawbacks, right? So they reduce vibrations, but not as much as luxury buses does. Luxury buses, and nowadays even new cars, luxury cars, high-end cars, so what they use is air suspensions. So air suspensions are basically, they remove that coil spring, and instead of the coil spring, they have got a rubber bellow or a rubber bag, and that rubber bellow is pumped with a compressed air. So there is a compressors and there is a air tank and all those things. So by which air is pumped into that bellow, which gives that stiffness, right? So which gives that stiffness, and these things. So these are actually part of active suspension system. So the old thing that you're talking about are the coil springs and leaf springs. They are passive suspension systems. But nowadays, technology is moving towards semi-active or maybe fully active suspension systems, where the vehicle height will change. I'm sure if you have traveled in luxury buses, you must have seen that sometimes the height will change. And so all these things, so they level the whole things, right? So otherwise, if let's say there is a vehicle with suspension, now if you have a lot of weight here at the back, the vehicle will tilt at the back. And if the vehicle will tilt, the normal reactions on all four wheels will be different. But in active suspension system, it uses a leveling system. So so even if a passenger sits at the back, it will pump the bellows at the back, make it again leveled, and again, so that the normal reactions are maintained, and which is all controls the stability and handling of the vehicle. So it gives better handling during cornering and those things. So, but the disadvantage of air suspension is that, you know, it's expensive, it requires more maintenance, and you have to have a lot of equipments, right? You have to have a compressor, you have to have a lot of mechatronic system, and air tank, and these bellows, and then maintenance of all these things. So that's the issue with these things.
So, Professor, my next question was related to the facilities created in research facilities created in your lab. So, I was going through your website, and I found that there are certain devices and equipments in your lab. I want you to please explain these particular terminologies for all the viewers who are watching this particular video. In your lab, there are devices like accelerometer, vibration shaker, vibrometer, and impact hammer. Maybe I have pronounced wrongly or correctly. So these are the terms I found on the website. Can you please explain us what are these devices?
Okay, accelerometer is the basic device for measuring vibrations.
Okay.
So even in our smartphones, and so many smart devices nowadays are coming up. So everything has got an accelerometer, but these accelerometers in our mobile phones, they are not very accurate. Right, they are very low cost, right? You know, the whole mobile phone, if let's say is few thousand rupees, then the accelerometer and the microphone to measure sound, these are maybe few hundred rupees or so, right? So they are low cost. This thing, accelerometers that we use in our lab, they have got a very good sensitivity, and they have got a wide frequency range. So they are used for doing any kind of testing, whether it's in industry or whether in automobile, or any kind of vibration measurements testing. So they have to be done with these scientific accelerometers, which we have in our lab. And so that's about accelerometer. Then we have got microphones. So microphones, as I said, again, the mic that we are using, for example, the one that I'm using, these are low cost microphones, but for scientific research, we use high-end microphones. So those microphones are used for a very important thing. One is called as acoustic material property testing. So if I want to test the acoustic property of some material, you know, how much absorption it has, how much reflection it will give me back. Acoustic materials are important, right? Let's say you want to go in an auditorium, you want to design an auditorium, if you have the malls or these cinema halls and so on. So they have these acoustic design of their walls, and those are done by acoustic materials. So those testing of those materials, we have impedance tube facility developed using the microphones to test the materials. And then we have shaker. So shaker is basically used to give a controlled excitation. So one time we have done a very interesting study where we have tested the accelerometer of a mobile phone with respect to the scientific accelerometer. So how accurate is the accelerometer of a mobile phone with respect to scientific accelerometer? To do that, we have to give a controlled excitation, right? I have to vibrate it at a controlled way, and that controlled excitation is given through a shaker. So that is another big machine that is used to give excitation in shaker. And then there is another thing, I think you said, the impact hammer.
Yeah.
So impact hammer is a hammer, but it's a special type of hammer that when you hit it, you will be able to measure how much force you have applied by that hammer. Right? So typically, so it is not used for hammering things. It's used to tap things to give a controlled small excitation, where the force is also recorded in the laptop. And of course, we have accelerometers to measure the accelerations of that object. So these things are used for actually getting the modal properties of an object, or I would say to getting the vibration characteristic of a system. So if I have got any object, let's say this muffler, right? Just now I have shown you this muffler. So if I want to test how this muffler will vibrate and or in which patterns it can vibrate, at what frequency it will vibrate, so all these things testing we can do it here. So these things facilities we have.
Okay. So Dr. Arpan, you have exposure of one of the best universities in the world. You are graduate from IIT Delhi, and then you have gone to National University Singapore. I'm sure you have seen the research facilities there also. So if I ask you, like, though it cannot be, I mean, comparison cannot be done, knowing IIT Mandi is relatively new IIT. But what do you propose? I mean, what is the vision you have for developing your own lab in the new Institute of Premium Reputation?
See, research area like acoustics and vibration require some equipments are quite expensive. So the one thing I was talking about to you is anechoic chamber. So that a special room for doing acoustic experiment that again can go into few crores. So that is a very expensive but desirable thing for acoustics experiment. So yeah, there is definitely a vision, but I would say it all depends upon the hard work and how we interact with industry and how do we take things forward, because like I have seen things like in IIT Delhi and NUS. So IIT Delhi has got very good research facilities. NUS also has got very good research facilities. But yeah, at new place, it will take time. It will take, may even take multiple faculties, right? So yeah, so that's it.
So Dr. Arpan, if you just pointed out about the relevance of industries also. So that was what my next interaction point was. Like academia and industry interaction is something which is very, very important. Right. There are experts like you who have knowledge of certain domains like NVH, which are so relevant. Now, in this region, there are industries also, and we keep on interacting with the industry people also. So they somehow they don't get those kind of expertise. So my question to you is, how can industry of the region where IIT Mandi is situated or located, this particular region, how can the industries of this region get benefited from the expertise you have in this particular field, that is NVH?
Yeah, it's a very good question, and I think that's one of your founding point about your whole interaction is to have an industry academia connect. I think it's very important, very relevant to do that, so that the knowledge gets translated into some things of common person, use something that can be useful for some people or in industry. So one thing is, I think industry should be feel free to contact us, right? I think that's what I would say. Our domain, our profiles and our email IDs are there in public domain, right? So we have our details there on the institute websites, and I think with the advancement of this basic technology, IT technology, industries should feel free to contact us. At least, so again, it depends upon professor to professor, but I would personally be very happy to connect and interact with industry, because see, we have a lot of students, we have a lot of, and we have academic understanding of things. And many times connecting with industry helps us to learn, right? So we are, as I said, we are also learning and connecting that theory with practical has its challenges, but that's where the fun is, right? So that's where you get some interesting problems. And as I said, if industry, let's say, contacts us, or we'll be happy to share the problem with our students. We have very enthusiastic students who really want to do something. So I would definitely look forward if for such an interaction. And simultaneously, from whatever side we develop or we do things, we also try to highlight it in some ways, in some form of media. So if the industry finds it relevant, then yeah, we can always contact us on email. That's
Yes.
the best way of contacting things.
Yes.
Yeah.
So that is very important actually thing, Dr. Arpan, because industries have their problems, so they keep on. The other day I was discussing, interacting with the one very senior professor of IIT Guwahati and sorry, IIT Kharagpur, and he told me that many of his students now working for some companies like French companies. So when metro and all in Kanpur and all is being designed, so we are seeking the consultancy from these countries. So why not at home when we have experts like you?
Exactly.
It should be done
Exactly.
here only instead of that far away.
And many times what also we do in industry, we just have a repetitive process, and we don't want to do something new. We don't want to try something new. Sometimes the fear may also be there that, if you go to IIT professor, he may charge a lot of fees or something like that. So again, I don't know.
That inertia is certainly there.
Yeah, that inertia, some kind of inertia might be there, because definitely there are a lot of industry problems are there, and thankfully government of India is actually promoting a lot of make in India things, and hopefully things will change with the lot of government initiatives. But yeah, instead of going just for things abroad, we should first give a try at home and see if things work out and what improvement can be done. And that's how I think things will progress. And then a point will come where we'll be able to export things to outside.
So my next point is even more relevant for today's transition stage in which we are, Professor, and that is related to e-vehicles. So we know that electric vehicles is going to be the future now. So electric vehicles have started appearing on the roads. Also, we see a lot of electric vehicles on road. So how do you feel that design of powertrain of e-vehicle will be different from that of a typical internal combustion engine vehicle which we see on the roads?
Okay, so electric vehicle is another area of my research and teaching that we have recently started. And as I was, recently we have started an MTech program in electric transportation here at IIT Mandi. So, so there are a lot of learning that is there in design of vehicles, how the vehicles are designed, talking about, let's say, said about powertrains or suspensions, as just now we discussed. So yeah, there is a lot of interesting work which needs to be done, and a lot of Indian industries are looking forward to that. So now coming to about your question on power train. So a typical IC engine basically has got a engine, then you have what is called as a clutch, then you have gearbox, and then there is maybe a differential, and then the power goes to the two wheels. So that's a major thing that is there in IC engine is the gearbox and this thing, which has to be reduced for a completely electric vehicle, a pure fully electric vehicle. So for electric vehicle have got these BLDC motors, which have got, at low speed, they can give a very high torque. So they have got a very good torque speed characteristics, and they can also go up to very high speed. Right now, IC engine has got a very limited range. IC engine has got very limited range, and therefore we need these 5-6 gears and the manual gearbox that we have to improve the performance from an IC engine to the wheels. But this BLDC motors have very good characteristics, so the transmission systems will be less. But at the same time, we can have, now there is a technology called as torque vectoring. So we can even have all 4 wheels driven by individual motors, or just 2 wheels driven by motors. So rather than, it eliminates the need for a differential as well. So it will, so all these technologies, will in the powertrain will have lot of impact on the upcoming electric vehicles. And in between, there are something what is called as hybrid vehicles. So we may not immediately transition completely from IC engine to fully electric vehicles, because we don't have that much charging infrastructure. Batteries have, as of now, they have certain limitations. So range is a problem. So the in-between thing that comes is a hybrid electric vehicle. So that has its own advantages and its own complexities, because it has both an IC engine and a electric motor.
Wonderful. So, Dr. Arpan, that brings us to an end of this wonderful session. But before I end it up, I have two more interaction points which are normally related to the students only, your prospective students. One I would like to ask you is like the domain in which you are working, NVH domain. That is quite a relevant domain. And after interaction with the more experts from industry and academia, I realized that there's a lot of scope, entrepreneurial scope also in our niche country for this domain. I want to take your opinion on this. Like, if some student pursues his research, or he goes in deep into this NVH area, are the opportunities existing, entrepreneurial opportunities in India for these kind of things?
Well, there are a lot of entrepreneurial opportunities available. Government of India is pushing forward a lot of schemes for budding entrepreneurs to showcase their new things and develop new things. So that is true in all areas, and NVH is no exception to that. So that is definitely being promoted. But yeah, NVH, as I said, it requires a good amount of knowledge, to begin with some knowledge, and then hands-on doing things, making things which are relevant to the common man or to the industry. So there is definitely a lot of scope in NVH for these things.
Okay. And my last question, Dr. Arpan, is related to prospective students. These institutes in which you are working, like IITs and all, there are thousands and lakhs of students who want to become part of such institutes and work with mentors like you. So my question to you is, when you take some student under your mentorship for masters or PhD or something, what do you see in those students, in your prospective students?
Well, in masters, you're talking about masters and PhD?
Yeah, I'm talking about masters and PhD, where normally the process goes through, like they'll be applying, they'll have interviews, they'll be showing their background or something, and then obviously you will take them.
Yeah, so as I said, for masters is still easier. PhD is a long commitment for the student and for the faculty, right? So so it is important to have a right matchmaking right in the beginning to evaluate whether I'll be able to guide the student and whether the student will be able to follow the things or not. So some of the, we generally, whether it's a written exam or interview process, so we basically test on the basic concepts of mechanical engineering. So if the student, the basic concepts are good, the student is academically good, right? Some of the things that I said in the first question. So for doing a PhD, the student should be in a good academic position, right? And one should be interested in, one should have a research, the research side of brain should be active, right? So he or she should be able to really want to do something new. So as a PhD student, PhD guide, we don't want to guide at every nitty-gritty things, right? And sometimes we may have to, but we would like that students to develop into an independent researcher. PhD is a training program, right? So we are training the student to become a good researcher and a good academician. So so that initial spark, that initial thing should be there, which is what we try to see. And then so the student is enthusiastic, and so then we definitely try to give
passion and enthusiasm is one of the important criteria.
Yeah, passion, enthusiasm, and as well as a background, a good background. So just passion and enthusiasm may not be sufficient, but there should be a good. So if he has done a BTech, then that BTech concept should be good. Same way, even for BTech students, if all BTech students come for doing projects, I would be definitely give preference to the students who are more good in academics and who have good understanding of things, they'll be able to do better.
Yes. Okay, so that brings us to an end of this wonderful session, Dr. Arpan. And let me again thank you at the end, because all the interaction points which I have jotted down, you have provided very straight and very easy to understand answers to all of these interaction points. And I look forward to visit you sometime and see your facility and your design experimental thing which you are trying to show, so that noise and sound part will be better that if we see that in the lab itself. So really thankful to you, and I wish you all the very best, Dr. Arpan, in your future endeavors.
Thank you, Dr. Vijender. Thank you for this interaction, and yeah, you're always welcome to to come and visit here. It'll be a pleasure. Yeah.